Okay, so question 2. The specific heat capacity of water is 4,190 joules over kilogram times Kelvin. Its heat of melting is 3.33 times 10 to the 5 joules per kilogram, and its heat of vaporization is 22.6 times 10 to the 5 joules per kilogram. For 1 kilogram of water, which of the following requires the most thermal energy input? Okay, so first, so for the question, they give us all these different scenarios where we have 1 kilogram of water, and we just need to calculate all of their different thermal energy inputs and see which one has the highest. So either melting ice at 0 degrees Celsius, heating 1 kilogram of water from the melting point to the boiling point, and then lastly converting 1 kilogram of water to steam at 100 degrees Celsius. Okay, so first I'll just talk about specific heat. So this will help us answer one of the questions. So specific heat can be denoted as C, and it is the heat needed to raise the temperature of a substance by 1 degree Celsius. So by knowing what specific heat is, this can help us calculate for Q. Since Q is equal to mc delta T. So m is the mass, and delta T is the change in temperature, and Q is kind of like the net heat transfer of our reaction. Okay, so basically we need to solve for all of the Q values of the different scenarios. But depending on whether or not you're heating, boiling, or melting, they all have a different way of calculating it. So there's also the latent heat of fusion. So this is energy that must be supplied to a substance or a solid substance in the form of heat to convert it to a liquid at its melting point. Okay, so again, we can calculate Q by doing mass times the latent heat of fusion. And for the last option, we have also the latent heat of vaporization. So this is the energy needed to change a liquid to its vapor state at its boiling point. So the equation to solve for Q is M times the latent heat of vaporization. Okay, so now let's look at all of our different options. For A, we would be using when we melt a solid and turn it into a liquid. This is the latent heat of fusion. So I'm going to write A here, melting 1 kilogram of ice at 0 degrees Celsius. So that means Q is equal to 1 kilogram, which was our mass, and the heat of melting was 3.33 times 10 to the 5 joules over kilograms. So Q is pretty much just equal to the same value, 3.33 times 10 to the 5 joules. Okay, so when we solve for B, heating 1 kilogram of water from the melting point to the boiling point, we would be using the first equation, Q equals mc delta T. So Q is equal to 1 kilogram times C, which is 4,190 joules over kilogram times Kelvin. And then I'll just put my temperature as 100 degrees. So this gives us a Q value of 419 kilojoules. Let me put the second one in kilojoules as well. And then lastly, converting 1 kilogram of water to steam. Q is equal to 1 kilogram times the heat of vaporization, which is 22.6 times 10 to the 5 joules per kilogram. So then Q would be equal to 2,260 kilojoules. Okay, so looking at all our different options, the reaction that requires the most thermal energy input is converting 1 kilogram of water to steam at 100 degrees. Okay, so let's see what the junior tutor said. Converting 1 kilogram of water to steam at 100 degrees Celsius requires the most thermal energy input. There are two types of heat, sensible heat, which involves the change in temperature, and latent heat, which involves the change in phase. Sensible heat can be calculated by Q is equal to mc delta T, and on the other hand, latent heat can be calculated by Q times L ml. Melting 1 kilogram of ice at 0 degrees gave 3.33 times 10 to the 5 joules. Heating 1 kilogram of water from the melting point to the boiling point is equal to 4.19 times 10 to the 5 joules. And then lastly, converting 1 kilogram of water to steam gave 22.6 times 10 to the 5 joules. So that's why C was correct. So this solution is correct.